And now Jeff Moffa, CEO and President of Auros Knowledge Systems, will take it away on AI and learning cycles. Jeff.
Thank you so much, Amy. So here we are. This is the third session of the breakout before we consolidate back to the general session for some really cool presentations later today. Please do stay tuned because they are extremely good presentations. I'm going to talk about AI and learning cycles. So to be perfectly clear, AI and learning cycles are coming. We're doing them, but we are in the process of really becoming, making this new technology useful and practical every day. I think we're there, but there's still a lot of opportunity that we are currently laying the foundation for. So when we talk about AI and learning cycles and machine learning in general, there's a couple things I want to talk about before we get into any practical demonstrations. And the first is, AI and machine learning are important elements of knowledge aware. So I'm kind of putting it out there that it kind of goes hand in hand with the second bullet point, that knowledge aware, the process of activating knowledge, gives us data about how knowledge is reused that allows us to have data from which we can produce insights through AI. Now, there's other reasons why you want to do AI and machine learning, but producing insights is fundamental to what we want to do. How do we create learning, or at least automate parts of the process of learning through this technique? And if you are managing knowledge in documents, you cannot get to the level of granularity of data you need to produce insights. If you have a paper map, you do not have the data about how fast other drivers are driving and in what time frames to be able to predict or to say there's traffic or not traffic. So if you are not tracking how knowledge gets used in the right level of granularity and how it's activated in the flow of work, you cannot produce insights. So you can have the best AI and machine learning algorithms in the world, but you're not going to get there without the right data. So knowledge aware at its essence tracks that data that's important for learning. And so it's just another reason that I feel that it's right for me to say and make the claim that knowledge aware is in the future of everybody. It's possible it won't be called knowledge aware in the future. I think it will, but if it's not, we're still going to be doing the fundamental elements of managing knowledge directly and integrating, activating it, and provisioning it in the flow of work. And we're going to create data and insights from it, which are the, basically the four steps in the cycle of knowledge aware. Then we're going to get into specific implementations of AI and machine learning, one of which is learning cycles. So learning cycles is a form of knowledge of AI-enabled stuff inside of specifically Auros, but knowledge aware. And it's a team-oriented concept. You'll see that, and they're designed to create new knowledge packets so that we're returning the process and creating a funnel of new knowledge. Okay, so that's kind of what we're going to try to get across, and I'm hitting it heavy because I want you to be aware of what we're trying to convey before we get to it. Okay, so specifically, what are we going to talk about? What are the demonstrations we're going to do? We're going to do proximity search, which is a lightweight form of AI. It's more statistical than what people might say is AI today, but AI is still all statistics in the long run anyway. It's fundamentally machine learning. The techniques that have become famous are all fundamentally based in statistics. Then I'm going to show you something called high cohesion clusters and what you can do in Auros right away today. And then we're going to talk about learning cycles that are built on top of high cohesion clusters. And then I'm going to talk a little bit about the document ingester and where the AI comes into play. Okay, so let's get into demonstrations. Let me slide over my first demonstration. So the first one I mentioned is proximity search. Now, proximity search is probably the longest lived AI technique built into Auros. It's been around for a while. However, in IQ3, it's been fundamentally upgraded. And I'm going to show this demonstration again tomorrow and what's new. But it's important for you to understand what's happening. So basically what this technique does is allow us to look at a specific knowledge packet or a specific issue and say, what else is there that's similar to it, right? And so it's a statistical matching of semantic probabilities of words existing in the same place relative to each other. It's far more than text matching. It's a form of artificial intelligence. So if I look at this particular knowledge packet that says desired engagement of center locator pins to hinge, okay? I can look at that and I see this icon shows up at the bottom. And you see it wiggles. And if there were issues that were related to it, it would show up too, but it found other knowledge packets. The symbol inside the circle tells us that. And when I click on that, I get a menu that comes up and it says that there's another KPAC out there, okay, that is basically at 0.998. So the score is a basic approximation. They call it cosine coefficient and the mathematics behind it. But basically, it's a measure of similarity where one is identical. So 0.988 is almost identical. These share almost identical to the same words, and you can see that. So Auros this statistical technique is very, very good at looking at a very large semantic space and finding areas of duplication. So what does that mean? When you have a system that is going to manage knowledge that needs to be trusted, copies are insidious into that process. And people will copy to take shortcuts. And so this will it's automatically found a copy. So here's one knowledge packet, here's another one that's a copy. The next one down in a different community, we find that somebody in the molding community is also interested in the minimum length of locators, or the first one is minimum and maximum. This one is just minimum. And we can start to understand what they think about engagement lengths of locators from a different community without ever having someone seen that there's two different areas of expertise or two different communities or two different domains, disciplines that are interested in communicating knowledge experience to users of knowledge using knowledge packets, that there's a similar concept, right? So proximity search is an extremely powerful AI-based way of finding knowledge packets and issues that are similar to the one you're interested in. It's kind of like going to Amazon and reading a book and it telling you these are the other books that match some kind of profile. And again, they're using machine learning techniques to do that as well. So this is proximity search. They're on issues and they're on KPACs. This example is on a KPAC. Do I have any questions on kind of what proximity search is and what it's based on and how it can be useful?
Why not? I don't see any written, but you want to tell us more?
If we don't have any questions, I got plenty of other material. I'll just
okay.
move on, and as questions come in, we can gather them.
I'll let you know. Great.
Okay, thank you, Amy. So I'm going to now move on to a different demo. And I'm going to start to talk about high cohesion KPAC clusters, or excuse me, this is issues clusters. So what I'm going to do is I'm going to just look at, so what this is it piggybacks on the statistical technique of proximity search. But what it does is it looks at all issues and starts to group them into naturally occurring clusters, right? And the clusters have something called a centroid, and the idea that there's issues that exist that are similar to one another identifies something where an action may be taken. So I'm just going to look down here and take a look at, for example, this one, right? Which one's a good one to look at? A typical issue cluster. And we find, issues that are clustered around a common issue. And you can see these are very similar related issues that were created around regression tests. So if similar issues are getting created, they'll be captured here in these clusters. We have a centroid of the cluster and these other issues that are forming around it. And we can start to quantify things that are happening in groups without having to observe it directly. Let the computer use the power of AI to find and identify the clusters, their sizes, their shape, and show you the issues that are around it. Okay, that's we call these high cohesion clusters. So this is an issues report. It's basically looking through all the issues, and there's a whole bunch of rules on how this works. But basically, it's saying, hey, here are issues. that are clustering and they're being created that are similar. Take a look, okay? And we also have something called high cohesion K-pack clusters. So again, it's similar proximity search, but now it's looking at all, instead of here's one knowledge packet, here are the ones that are similar. Now we're saying, where are clusters forming around specific K-packs, right? So you'd want to do the same thing. So now here, this looks a lot better in a demo for with engineering data, but this is in our consulting business. We call this the seed opportunity pursuit community, and there's a bunch of standard work K-packs here. And if you look at these, we get the same idea, right? So here are two K-packs that are talking about how to figure out who should be on the team as we onboard a new customer. These are very much related topics, and Auros has identified them as related. And as different people, different work groups came together, you could start to see that happening, right? And different knowledge packets being created across different domains. This would collect them all, the similar ones, and allow smart people to make connections and learn from what the system is doing. Okay, so that's high cohesion clusters. So next I want to talk about learning cycles. So learning cycles are a third level on top of that. So we started with proximity search, right, which is this ability to find related items. Then we add the clustering to find clusters. And then we present in a learning cycle a methodology, a curated process for creating that's based on a learning opportunity source. So what we did in IQ 4 or 5 is to create a tile called learning opportunities. And basically what the system does is it takes an AI indication, so a cluster of issues, a cluster of K-packs, and there are other sources, and it puts it into a flow of work that is also AI enabled for people to then decide whether there's a learning. So I'm gonna go to my learning opportunities. And I got this little panel here that says I got 5 pending and 1 where I've decided I'm not gonna participate. So I'm going to go into that, and I've got 1 user-initiated learning opportunity, and a bunch of learning opportunities are based on an issue cluster, okay? So if I go to, for example, which one do I want to use here? I'll go to this bulk builder one. Now let's go to this one.
And Jeff, we do have a couple questions when you're ready.
Yeah, please, go ahead.
Okay. Mauro is asking, what is the main benefit of proximity search? Is it finding unintended duplicates?
That is a single benefit. Yes, that is probably one of the top 3, but it's also very good at finding connections to other work groups that are authoring knowledge packets over similar topics. Like, let's say I'm in the world of an automotive OEM and I'm designing a hood, and I'm trying to design the way the inner panel and outer panel of a hood mate, right? Well, the sheet metal guys may say the right way to do that is a downstanding flange because it's easier to get a weld tip on. The studio may say I want a rope flange because it gives a better margin, hood fender. And the manufacturing engineer may say I want a standard flange because that's reduced the cost of manufacturing and scrap. So there could be knowledge packets about flange design for hood, inner panel, to outer panel written in 2-3 different communities. And you may know about this connection, but you may not. But if you went in any one of those K-packs and clicked the proximity search, you would find, oh, there's a point of view about this from the studio. I didn't know that. And proximity search helps to make those kinds of connections as well. Now, in reality, customers are just starting to adopt proximity search, and we're in IQ4, we put a lot of tunable parameters that customers can kind of start to tweak how it works, how it matches, and we're kind of just getting our feet underneath us for that. But I can tell you that I use it in issues management every day. I find a customer reports an issue, I can click on it, I can find other customers that reported an issue that's similar, and it works about 80% of the time. I can find somebody created an issue on that same topic without having to search for it. Right, just click, it shows up. I know someone created an issue that's similar, or I can see these issues are this one feature of Auros is getting a lot of issues. Why? Maybe fundamentally the design's bad. Let's rework that. Let's look at the design of that particular system. Great question, Mauro.
Yeah, and they're really starting to stream in now. We've got a bunch queued up here. Is this a good point to take
Please.
some more? Okay. So Jeff is wondering, are proximity search high cohesion K-packs themselves a learning opportunity?
Yes. That's in IQ5, yes. I'll be talking about that more tomorrow, but yes, high cohesion K-pack clusters also are a learning opportunity as of IQ5. And we'll continue to add AI-based learning opportunities. Like we have a bunch of ideas on how we're going to do, analysis of how long a process takes, right? And can we start to use machine learning to decide there's a learning opportunity when one kind of project continually goes longer than another kind of project, those kinds of things.
So it's not just for writing new, it could help combine obsolete, he was asking.
Basically what we're saying is the learning opportunity is independent of its source, and we're continually finding new sources to start the learning opportunity process that'll be machine learning based.
Okay. Now, Stephen is wondering, well, he says, great presentation, by the way. Just curious, but do the AI features overlap into the partner portal as well? And if so, is there full functionality or can it be restricted to a degree?
It is not currently propagated to the supplier interface on purpose. So that's something that will require a lot of discussion with our partners, as we understand. But we currently want to keep that an internal facing tool, just to ensure that the integrity of the system in terms of access control is maintained.
Okay, that makes sense. And Nicole is wondering, how do the learning opportunities get assigned to someone? You are an author to the K-pack?
Nicole, you are great at setting this stuff up. Thank you very much.
Right?
Yeah. So let me just talk a little bit about learning opportunities. So learning opportunity, as I mentioned, is a curated process, right? So I've been identified as a member of the team to look at a learning opportunity. So this learning opportunity has to do with bulk build. You guys can see that it was an issues cluster, and there's a whole bunch of issues happening with the bulk build that are similar. So I get to decide whether I want to participate in this as a learning opportunity. It's going to go through waiting, forming, working, action taken, action no taking. So Nicole's question, the first thing that a learning opportunity does, it looks at all the issues in the cluster and finds out who's been working on those. Now, interestingly, it's a small number of people. You would think these issues would be more, but really, these are the two developers and me, and actually Josh are the ones working on those issues or been assigned to them or have some role on those issues. So that's cool. But there's another reason that Josh may be here is because Auros also looks, since it's an issue cluster, it's going to also look at K-packs. And if it was a K-pack cluster, it would also look at issues. And if it were an independent source, it would look at both. So here it's just showing me K-packs, and it's finding regression tests that have to do with bulk build. It's having regression tests and single point lessons on assessment controls and how they're built. So it's finding related information, looking at that related, knowledge aware data structures like assessments and issues, and identifying the people that may have dominion over this learning opportunity, and it's selecting them and telling them, hey, do you want to join this learning opportunity? It's basically, the concept here is a self-selection. So we're the people that have been, nominated by the system, and I can claim the lead or not claim the lead. As soon as someone claims the lead, it'll move into working. And we can also invite other people. So we can say, oh, I know someone who should be on this team, and then we add them, right? So I can opt in or opt out, and then if I opt in, now it's part of my learning cycle, it's forming, it'll start to working soon, someone's claimed lead. But now we can do our research in the related items, we can look at the cluster, and we start to build conclusions, and we add conclusions, and then we can assign those out to other people to create knowledge packets from them. And I'm not gonna get into the details of that process, but you get the idea. So basically, it's a curated process for creating knowledge packets and providing built-in research mechanisms that looks back at issues in K-packs that may influence people that may influence. And I believe there's a tremendous opportunity to hand. It is still growing in terms of how well refined the process is, but we're just getting started. I have strong belief based on early results that this will be a tool that will unlock tremendous value if you're going down the knowledge aware vision, because you need the data to be able to do this, right? You can't have documents and understand, who's using what KPAC, where the copies are and things like that. You can't. But if you have knowledge packets and people are using them, you do. And you can start to do this kind of analysis, present it to users, and create a process to create a new learning, which then is a knowledge packet. And it kind of goes back and forth. So this is knowledge. This is a learning opportunity. Again, we're going to show a little bit more of this tomorrow at What's New in Auros, but that's kind of the concept. So hopefully, Nicole, that answers your question. The people get appropriated by the system based on what they've done in other tools and other things that are relevant to the learning opportunity, as well as you can nominate people.
Yeah, I think Nicole's satisfied based on her comment. She's excited to start using it. And then we do have one more question from Cole. Are these AI features going to be applied to assessments at some point?
Cole, good question. Yes. We absolutely attend, like I said, we plan to do it with methods, we plan on doing it with assessments, non-conformances, everywhere where we can pick up a signal from the data and how knowledge is getting used, and it's rife with opportunity. And so, as you know, we started with issue clusters as an opportunity, then we went to KPAC, high cohesion clusters as an opportunity, we added ad hoc sources up as to begin an opportunity, so you can just type in, I've learned this, and then it'll do the research, appropriate people, just to create. So Jeff Mayhew mentioned that, they had a process where people can write a KPAC that says I need a new KPAC. Well, this would be another way of doing it that could curate the process all the way through.
Okay. Do you have time for another one, or you want to cover?
No, let's go ahead.
Okay, Simone says, I'm collecting engines, thermodynamics around the globe. Are you able with your software capability technology to collect all the data from the cloud and do analysis prediction? And how long would that process take?
Yeah. So no, we're not currently set up to be a general purpose AI tool. What we really are doing is using a very well engineered AI stack to do machine learning and AI within Auros on the data collected by Auros on how knowledge is getting reused, with some exceptions. Mm-hmm. But by and large, we don't want to be a company that sells AI tools. We want to be a company that produces insights in our tool about knowledge management without the need for AI expertise, right? You're just getting the insights. When you drive down the road and Google tells you there's traffic ahead, you don't care how they did it. You don't care, you didn't have to wire things together. You just got the benefit of the insight that was created through AI. Our vision for AI and Auros is to do that, is to enable the process to produce those insights for individuals without them really having to worry about machine learning is even present. So we don't have the tool that says, okay, go index these documents, figure out correlations, produce an insight from the, resulting, deflections or resulting heat transfers and stuff like that. There are tools, math and stuff like that are better suited for that kind of thing.
Okay. We have one more question. Is Auros AI engine language-based only, or does it also look at numeric parameter values?
We have a whole bunch of AI and statistics-based stuff on parameters already. I'm not including that in this demo. We do heuristics around, mins, max, means of parameters as they get explored. We trend that. I love that feature of Auros, so I don't get a chance to show it that often. But when you get into a lot of value tables and tracking parameters and KPIs, we have that feature. And it will eventually be our new, I do want to talk about it. Auros, we've engineered a machine learning technology stack. We built it into the system. It's new for us so that we can have, models that improve themselves over time. You have to build out that stack. We have that in place. And so adding, an insight engine, a model, a machine learning model that produces insights, a new one will fit into that stack well, and we can add these like the ones that might explore or predict trends in parameters in value tables, which is, I think, where that question is going. So the answer is not right now, but we've built the foundation for that.
Excellent. Jeff, is there anything you feel like you haven't got? We have 15 seconds. I mean, we could go over a minute or two, but did you need to say anything else?
The only thing I want to, I was going to talk about the document ingester.
Okay.
The document ingester takes a PDF document or other forms of documents, creates knowledge packets of it. There's a lot of AI built into that, character recognition, there's a whole bunch of stuff. And it also auto-classifies and predicts values for extended elements. I'm going to talk about that tomorrow, so there's no reason to go into it detail right now.
Okay, great. And thank you so much. I have pasted the survey link as well. You do have to copy and paste it into your browser. And I want to let you know our next general session begins in 5 minutes at 3:50 with Josh Cullis, Technical Services Manager and Knowledge Aware Consultant at Auros. So we'll see you in 5 minutes.
Thank you, Amy.
Okay, thanks everyone.